So this session is about interview questions on the statistics. So first of all, I would like to thank you everyone. You joined the session, right? So the expectation of this session is that these are the straightforward questions. I have picked up 10 questions, which will be, which are, constantly asked in a certain interviews, right? So I have just take out the concept and I have wrote the question. But once you go for actual interviews, right, so it will be not asked you directly based on the scenarios, right? They'll give you certain scenarios. Yes, so we were discussing that some scenario based questions will be given to you and you have to apply the concepts and then you have to answer the statistics interview question. So always remember that there will be no straightforward questions will be asked on statistics. Okay, may possible in few of the small scale industries, if you are applying for startups, they can ask you, but in MNCs, if you are applying, right? So yeah, it will be not, it will be completely a scenario based questions, right? Fine. So let me check. Okay, so let's start the session, right? So I want this session to be interactive, right? First, I will ask the question. You need to write the answer and share it in the chat. Okay. And based on that, we will try to answer it correctly. Okay. So 1 second, just give me a second. All right. So let's get started. So the first question is examples of left skewed and right skewed distribution. Right. So fine. So just put your answers into QA section. Okay, no answers. So you don't know. I'm not asking here what is the left skewed and right skewed. The question here is examples, means which variable follows the left skewness and the right skewness. So try to answer. Okay. So Sumit is telling salaries in organization. So this will be right skewed or left skewed? Okay, till that time you people answer. I'll prepare a notebook so that I can share you later. Guys, if you don't know, no problem, just Google it. At least by Googling, right, you will able to recall, right? You will, it's not like, right, you can remember everything. So just Google it, no problem. But at least try to Google. But not during interview. Right now, you can do it. So the question first was examples of left skew distribution. Okay, so, okay, I got answer from Sumit only. I'll wait for 1 more minute. Guys, please don't listen to the what I'm saying. Just do what I'm trying to say. People are joining late, So for them, I'm repeating again that we need to find out which particular variable follows left skewness. Okay, Prashant, right skewed height of student. All right. Okay, so Basava is telling, Basava and Prasad, right? Okay, so right skewed of height of the student, age of the deaths. Okay, right. For the left, we can take. Okay, so let's get the answer here. So answer for this first, let's say we have distribution of age of deaths. Okay. Distribution of death. Okay. Apart from, correct. So Prashant will be. So first of all, for that you should understand what is left skewed data. So left skewed distribution is something, a distribution like this, okay, which has a skewness in the left side, right? This is called as left skewed data, or it is also called as negatively skewed data, okay, or distribution, right? So distribution of age, right? So if I consider ages here, right? So usually if we take death rate of India, so what is the age? So usually it's 70, 80, right? This is the life expectancy of the Indian people, right? Similarly, we have, so this answer was given by Prashant, left skews exam scores for relatively simple exam, right? If, okay, so you can say that if exam is simple or easy. So let's say basic Python exam is going on, right? And in that scenario, you will be end up having a left skewed distribution because mostly people will pass. So like this, we will be getting a left skewed distribution. Okay. All right. Okay. So these are the two examples of left skewed distribution. All right. So somebody asked you, okay, in the same question, what do you understand by skewness? Now the next question is this. What is your understanding in a very simple way, right? Let's assume your interview don't know what is skewness. How you will explain him the skewness? I want the, not, I don't want a technical answer. I want basically a very layman example, right? Distribution of data. Skewness is distribution of data. Is it? Try it in a very layman term. Okay. So skewness will be influenced by outliers in the data. Yes, that is an influence on the skewness, right? How skewness occurs in the distribution is because of the outlier. Mean does not coincide with peak value. Okay. Data concentration, distribution of data which is moved to either side. Yes, almost correct, Sumit. So yeah, Sumit answer is correct. So what is that? So the word here will be symmetricity. Okay, so symmetrical distribution. Okay, if your distribution, okay, whatever distribution you have, okay, if it is not following symmetricity, okay, the word here is symmetricity. Okay, so the meaning of symmetricity is identical on both sides. Okay, or there is another word called as mirror images. Okay, if your distribution is not following mirror images, so the layman term should be mirror images. Okay, then it is called as skewed data. Okay, clear? Skewness. Correct. Asymmetric distribution. Measure of symmetry. Correct. The degree of asymmetry observed in the probability distribution. Correct, Niharika. All right. Okay. Now let's move ahead and try to see examples of right skewed distribution. Okay. So I have got answers for this. First, let me write it down. Salaries in the organization. Okay. So for this, answer is salaries in the organization. Okay, so first of all, right skewed distribution. So distribution that is skewed toward right side. So I can represent this like this architecture. Okay, so mostly right, the average salaries. Okay, how is this right skewed? Which one, Aniket? So if you see here, right, see, this is the scale, right? So initially, let's say somebody started with 10K dollars, okay, then 20K dollars, okay, this is dollar, 30K dollar, 40K dollar, 50K dollar. See here. So basically, as in salary increases, number of employees are increasing, right, in the organization. So basically, what I'm trying to say, if you follow an hierarchy in the organization, so we will have freshers, right? So we will have freshers. So freshers will be getting in this range, let's assume. Then we have 1 to 2 years of experience, 3 to 4, then 4 to 5, right? So till CEO, right? If you take CEO of the company, he will be getting, right, very high salary. So hence, because of this, the distribution will be right skewed. Okay. So whenever you try to understand any distribution, guys, remember this. This is in the increasing order. I hope, Aniket, you got your answer, right? The distribution, right skewed. Right. One more example. Distribution of household incomes. Okay, so same example. Okay, one more example for right distribution. Okay, so just the way we have taken here. Okay, scores in tough exam. Okay, so there will be less people who will get high marks, right? So this will be the right skewed distribution. Okay, any other examples? Please try to find out. Yeah, one more example that would be easy. Just try to see in the Google, you'll get lot of answers. Okay, no answers. Okay, 1 second. Mileage versus cc of engine. Yes, correct. Ankita, real estate prices. Yes, as the size of house will increase, right? The price will increase. Mileage versus CCC. Okay, cc of engine. Okay, so 4 examples we got here. Mileage versus cc of engine. Fourth, basically real estate price. Okay. All right. So this was all about the skewness, what we can say right skewed and left skewed data. Demand versus flight cost. Yes, correct, Manjunath. Demand versus flight cost. Correct. All right. So this is how the examples of left skew and right skew data, right? So if you recall your statistics lecture, right? So there we discussed how this is basically how the skewness come into picture, right? And what are the ways to handle it, right? But yes, this particular question was asked, so I thought of discussing this with you. Okay, all right. Clear? Anyone having any question? Okay, so let's move ahead for the next question. Okay, so mean, median, and mode relationship between right and left skewed distribution. I hope this everyone knows, right? So the question here is relationship between mean, mode, and median for skewed data or skewed distribution. Yeah, come on. So look it. Okay, till that time, what I'll do, I will take some images and we'll try to explain. Till that time, please share the what is the relationship. Okay, so we'll take image over here and yes. So this image is very Wikipedia page. Let me put it here. Okay, so Prashant is telling, Prasad is telling, right, for right skewed data, mean is less than, median is less than mode. Okay, if distribution of data is skewed to the left, the mean is less than the median, which is often less than the mode. Mean is less than, correct. Yes. So see here. So always remember when this question will be asked to you, what you have to remember. Okay, you need to remember only symmetrical distribution. For symmetrical distribution, mean equal to mode equal to median. Okay. Now see here where this skewness is. This skewness is right skewed or positively skewedness. Okay, so for positive skewness, what you will have first, see mode is coming. So if you look here, mode is less than median. Okay, mode is less than median. Okay, and median is less than mean. Okay, so whenever we have positive skewness in the data, right? So mean, so basically mean shifts towards right side. Okay, that means the mean value increases. Okay, so the mean value is the highest value. Okay, mean will be the maximum. Okay, so now let's discuss on the negative skewed distribution. In that case, see here what we have: mean shifted toward the skewness side. So mean will be the less. So mean will be less than median. Median will be less than mode. Okay, and mean will basically your mean will shift. Mean shifts towards left side. Okay, now you can create a shortcut for here. Okay, you can just remember which side mean moves. Okay, and based on that you can check which other you can verify. Okay, so this is what the shifting happens into the. So always see in the skewed distribution, median remains in the same position. If you remember where mean is shifting, then you can identify easily where mode and mean will be shifting. Okay, so this is how you will remember the shortcut. All right, clear? This question is clear? Okay, now let's move towards the third question. Okay, so what are the different types of sampling? Let's do that. Okay, so this question was asked like this. Okay, so I'll give you a scenario for this question. So the case was like this. Okay, the interviewer asked, let's assume we have elections in the city, and we need to let's say I'm a media person and I want to perform the exit poll. Okay, so for exit poll, what is the process of selecting voters for exit poll? So this was the question that was asked. Can you tell me? Okay, so Manjunath is telling it's random sample. Okay. No, Sumit, you need to just, remember this, where the mean will shift. It depends on this, your skewness, right? For skewed and not skewed, mean, median, mode is always equal. So from there, you can decide. If the balance between mode, mean, median changes, then it is a skew. Stratified sampling. Prashad is telling stratified sampling. Okay. Random sample without replacement. Okay. How about others? Systematic sampling. Okay, getting different answers. Others, please try it. Okay, so here, if you look, why we are getting multiple answers here, right? So the reason here is that it depends upon the agency, right? So whoever is giving me has given me answers, everyone's answer is correct. Why it is correct? So you need not to say any specific sampling name. You need to say that it depends upon on let's say the company or the organization which is doing this exit poll. This is very what we can say exit poll, not exist poll. Okay. So they can take any criteria for that. Okay. So now can you define criteria? So criteria can be, right, students, a student group, a group of students. Okay. A group of BPL. Okay. So those people who belong to below poverty line, right? Third can be regional wise. Regional wise. Okay. We are talking about, election in a city. Male, female, right? Male, female also they can take. So there are multiple, criteria to decide on the exit poll. Okay, so it might be possible if a female candidate is uh, uh, is ha, uh, is trying to contest for the election, right? So in that scenario, it's very important to see this male female ratio. Okay. All right. So as people said, right, types of sampling. So here we don't use any sampling, but yes, let me quickly discuss about the samplings which we can be used. Okay. So simple random sampling. Okay. So to select people from this group, right, they can use random sampling or simple random sampling. Okay. Then we have stratified sampling. And it is again random sampling. Okay, so here what we do, we create a certain group and the groups are called as strata, right? Okay, we do cluster samples also. Cluster, random sampling also. Okay, and fourth, systematic. Okay. So these are the 4 ways in which you can sample the population for exit poll. Okay. So ideally, whenever this kind of exit poll question comes, you need to first tell them this, and then yeah, you can tell them for this kind of thing, we can say random, stratified, or cluster samplings can be used. Okay. Right, let's go ahead and see the next question. Difference between population and sample. I hope I mean not to tell this. You guys can tell me. I want everyone who has joined this webinar, please tell me what is difference between population and sample. Yeah, please tell me. Okay, sample is a subset of population. Correct. Simple one term answer is sample is a subset of population. So I can say population is a big group, and in that big group, if I take certain number of observations, that becomes a sample. Okay, so this is the main difference between population and sample. Yes, sample is a subset of population, population collected of whole data. Population is an entire group. We are selecting a particular group from that entire group. Correct, Ankita. Okay, over to this, right? There is one more question I haven't written over there, but I'm writing here. So, which was asked in one of the interview. Okay, why do you need samples to do statistical analysis when population is already there, right? Why do you take samples from the population? Why don't we do entire analysis on the given population? Can anybody tell me answer of this? This is a very good interview question. So just try it. Population considers as a whole group, computationally expensive, time consuming. Correct. And everyone does not have access to the population. Right. Time consuming. Correct. So time consuming, expensive, and less access. Okay. So this is the reason. You can give an example of this when we go for a blood test. Okay. So the pathologist can take entire blood from your body. No, they take sample of the blood from your body, right? So you can give this example as well. Okay. All right. So this is about the question. Complexity, time consuming. Correct, Nafal. Okay. Okay. How descriptive statistics is performed? Okay. First of all, you should know what is descriptive statistics. How descriptive statistics is performed. I would say how to answer this question. Okay. So to answer this question, what you do, you set a target. Okay. So you need to set a target to answer this. Set the target. Or activity. So that will, help you to understand or to explain what you're trying to do in descriptive statistics. Okay. So let's say my task is, or basically task is to see what are the important factors creating risk of malaria in given locality. Okay, so I want to know what are the important factors, okay, and how many people are getting impacted by this particular malaria, okay, malaria or dengue, all this kind of diseases, right? So now my task is defined. This was the step 1. Step 2 would be, sorry, defining features. Okay, now tell me, to do the risk analysis of malaria, what factors you should consider? What can be the features? Okay, data from doctors, hygiene, hygiene of the area. Okay, right. So if I want to analyze a certain area, right? So first I need to check how many patients are there, how many people are affected with malaria. Okay. Now, once I got to know how many people are there, then I need to, do survey on the patients about the severity of malaria, right? What were the sources which caused malaria, right? So in our case, mosquitoes are the what we can say creature which are responsible to get the malaria, because malaria cannot be transmitted via air. Okay, only the mosquitoes can do it. So we got to know malaria is the basically mosquito. But okay, we got to know, okay, malaria is power, but what are the reasons why mosquitoes are getting developed there? Is there anything open, the hygiene, right? So all this comes into in this case, right? And finally, okay, finally we can create a report on it. Okay, so step 3 will be, okay, once we define the features, right, next will be I need to do the survey. So for survey, sampling strategy, which samples to select, which samples not to select. Okay, so right now in this particular scenario, we are focused on a given locality, right? So you can say we know need not any what we can say sampling technique, right? We can go individual house and we can do it. But if the locality is very big, then we need to follow any kind of strategy, right? After that, fourth step would be creating insights from the collected data. Okay, it can include forecasting whether if the scenarios, right, let's say some open water bodies are there, unhygienic situations are there, if this continues, they can predict how many numbers of people again will get impacted, right? Even statistician also do the work of forecasting. Okay, but they do it with the help of manual methods. They don't use machine learning initially. Enough new, now they are using, everyone is using machine learning for this. Okay, so this is what you will define as a complete end-to-end descriptive statistics. Okay, right. So whenever this question comes, explain with the example. All right, any question? What are the symptoms? Yes, correct, symptoms also you can say. Environment, correct. All right, let's see our next question. Explain central limit theorem. All right. Now, please tell me what is central limit theorem. Okay, no answers till now. In any shape of distribution, if we take out the samples and calculate sample mean, plot, then it will be a normal distribution. Correct, Prasad. Correct. So as Prasad said, it doesn't matter what is the distribution, okay, of any population. Okay, this is the population. If we take out the samples from this, okay, say sample 1, sample 2, sample 3, and sample 4 till sample n. Okay, and if we take mean of each sample, mean 1, mean 2, mean 3, mean 4, and mean n, and if we plot this, all the means, okay, this mean will follow normal distribution. Okay, so mean will follow normal distribution. Okay, fine, but what is the use of this, right? So you after explaining this, you need to tell why central limit theorem is used. Can anybody tell me why do we use central limit theorem? To analyze large set of data, okay, outlier detection. Okay, what else? Right, so as Sumit said, to analyze large set of data, right, when we have, okay, so application includes, okay, or to extract samples from population, or good samples from the population. Right, so you remember whenever we start with statistics, right, whenever we do sampling, we try to bring that sample which is best representation of population. Okay, let's assume we have taken this some set of samples here and we have drawn a distribution here. If this does not follow normal distribution, that means these samples are defective. We need to resampling. We can go ahead and bring back new samples, and we can do sampling till the point we don't get a normal distribution. If we get a normal distribution, we can simply take this set of samples and we can do analysis on them. Okay, so this will be the example to extract good samples from the population. Okay, so this is the example here. There is another application, designing confidence interval. Okay, so usually what we do is that instead of taking, right, whenever we do sampling, right, once we get the samples, right, if we try to do any estimation on the population, right, instead of taking a point estimation, we can use confidence interval. Confidence interval is that in which we do estimation on population, okay, in range. So for that we can use central limit theorem. So these are the two applications which we can help you in giving more detail on central limit theorem. Okay, right. Okay, now the next question is, what is probability density distribution? Okay, give it a try. Have you ever heard about this word? What is probability density function? Just give it a try. Okay, please find link for this answer notebook. So probability density function. So it is the equation of the curve of any distribution. Okay, but what does this distribution refers? Okay, so in the y-axis, we have probability, and in the x-axis we will have observations value. Okay, so this is what the probability density function is. Okay, so basically it tries to establish relationship between the probability, right, or it calculates. Okay, so in a mathematical terms, PDF calculates the probability of observation lying on the curve, lying on probability density curve. Okay, so if I represent this, let's assume I have a curve like this. Okay, so I took samples and I did some analysis over here, and I found the distribution of the samples which I have taken is like this. Okay, now I want to know if a new observations is there. Okay, so let's say this is a height data. Okay, I want to know if new height is coming, what is the probability of that new height to be present in this curve. Okay, so basically that is calculated by PDF function. Okay, so this is the probability and this is the height, right? Okay, any question? Okay, now let's move ahead and see what is variance. Now this you can tell easily. Okay, so I'll tell you, variance means, it means how much observations are different from mean, from average or mean. Okay, this is the definition of variance. And example to understand in very layman term, right? If the interviewer asking you to explain variance, right? So you can give example. Let's say in a college, right? Let's say there is a 60 students in a given batch. Okay, right? And they have written exam on maths. Okay, so 60 scores will be there, and let's say the scores, maximum scores are, when I say maximum score means basically the limit here 100. So each of the 60 students will score some marks here, right? So if the college want to do analysis, on performance of maths exam or maths scores. Okay, so see, based on the maximum marks students are getting, on that we cannot evaluate any subject. Okay, right? So what is that? We need to find out the variance. That means, let's say student 1, student 2, student 3, like that we have student 60. They have scored certain marks, right? So one has scored 15, 60, 63, 21, 22, Like that, they have scored certain marks here, 58, like that. Now, out of this, first what I'll do, okay, I will not simply do the analysis. So how 15 varies from 60, right? Because see here, the data is very, it is as per student. If I go and change between S1 and S2, I swap S1 and S2, again, I cannot establish the relationship, right? So in such scenarios, right, what we do, we try to calculate the mean of this. So first of all, we will calculate, we will sum all the marks, okay, and divide it by 60. We'll get the mean here. Now we will take this 15 and we will calculate variance of this particular 15 from the mean. Similarly, we will calculate this, and this will give us how these two numbers are varying from each other. Okay, and this particular concept is known as variance. Okay. So try to get one more example for variance. What can be the other example? Okay, you can say, let's assume you are investing in stocks, right? So let's say you are gaining profits from few months. So you can analyze your profits, how they are changing. Okay, so that can be the another example. So usually the variance is used by trading companies to analyze how losses are going, right? How profits are going. Okay, so this helps them in understanding, and even it helps in them for predicting the values as well. Okay, now let's move ahead and see the next question. How about bias? How it will differ from variance? Basavaraja, where are you? This is a statistics variance we are talking about. Okay. The next question is, what is normal distribution? Why this distribution is used in machine learning? Okay. So what can you explain this? What is normal distribution and why it is used in machine learning? Yeah, please try this. So simple normal distribution, you can explain it is a probability density distribution which is symmetrical about mean. Okay. About mean. Okay. And it has a bell-shaped curve. Right. Okay. Now, why it is used in machine learning, that you have to tell me first. I will not tell it directly. You need to tell me. Because see, whoever has joined this session, I can see they have already completed their machine learning part, right? So try to give answer for that. Okay. Reduce the noise in machine learning. Normal distribution helps in understanding spread of data. Okay. All right. So if you see here, for algorithm, whatever algorithm you use, right, for them, it does not matter the shape of distribution. Okay. What matters is that loss. So the loss function that get impacted by the normal distribution. That means, right, the distance-based algorithm. So what are the distance-based algorithms? KNN, right? SVM. Then we have linear regression, logistic regression, right? So basically here we try to fine tune certain parameters. The tuning of parameters basically means reduction of loss function. So reduction of loss function, right? So whatever losses we calculate, right, on a given observations, right? If we plot loss for each variable or each observation, okay, and it follows normal distribution, then convergence become very easy, right? Become easy, okay? Convergence means basically getting the optimal values, okay, getting the optimal hyperparameters. So in case of SVM, okay, what can be the convergence? C and gamma values, right? In linear regression, basically it would be your weights, right? In logistic regression also weights and bias, right? So in KNN, number of neighbors, right? So that means the convergence. So if the losses are coming to be normal distribution, the convergence happen faster. So in that way, the prediction will become easier. Okay, so this is the reason why it is expected that right, that we should have normal distribution. We should have normal distribution for the losses, not for the variable. Okay, so be super careful. Yeah, if in case we have normal distribution, good to go. And as such, there is no relationship. But if we have normal distribution, then good to go. Okay, right. The next question is how correlated features impacts the machine learning algorithm. This is very important question. First, in this scenario, what you have to do whenever you have been asked this question, first you need to explain what is correlation. Right? What is correlation? Relationship between two features. And in machine learning, it is linear relationship between two features. Okay, you have to always remember this. Correlation in machine learning is a linear relationship. Now, what is linear relationship? If quantity of one feature is increasing or decreasing with respect to other, that kind of relationship is known as linear relations. Okay, right. Now you need to tell how it impacts the machine learning algorithm. So the impact is that training time increases. Training time of algorithm increases, right? That's all. That's all you have to tell. Right. So yes, guys. So 1 second. Okay. So this is what the answer is, right? Okay. So that's all for this this particular session, right? We have covered our all 10 questions, right? Okay. So right. I have shared this notebook with you. Recordings will be also available on the request basis. Okay. So if you have any other questions, please let me know. And yeah, before dropping, right, I wanted to know, right, can you give me some more questions on statistics? You might be, attending interviews, right? So you might have faced lot of interview questions, right? Or if you can suggest me what topic should I cover next in statistics, or any specific topic you need, so we can have a webinar on that and we can discuss the things, right? So please do provide me the feedback. Okay, what is hypothesis and type 1, type 2 error? Yes, correct. Okay, so I'm noting down all the options. Yeah, so anyone having any questions, you can start putting in the QA section. Okay. Okay. Hypothesis testing in machine learning. Okay. Interview question on Python, which we have not performed in class. Rakesh, there is a practice set question, right? It contains 500 interview question itself, right? So they have been asked into interviews. Okay. So Python is a very, vast concept. So yeah, basically check that one. And even if you feel, you can tell me what other questions I can take. Tail 1 and tail 2 test. Okay. P-value. Yeah, right. So P-value will be covered into the statistical test. P-value also. What is P-value? Yes, most of the time it is asked. Okay. Matrix is to classify the regression and classification accuracy. Okay. Okay. Confidence interval and curves of dimensionality. Okay. Hyperparameter tuning. A/B testing. Okay. Hyperparameter tuning is with respect to individual algorithm. Okay. So right now I'm taking interview questions on statistics. So yeah, but anyways, I will note it down. So hyperparameter tuning can be done. Pearson coefficient, just now I have explained, Basava. A/B testing noted. Okay, all right. So I have taken all the questions, but it's not like, okay, these are the only questions. If you feel some more questions should be capture, you can just mail us on internship@datamites.com and we will take the request. Which data works on which in certain ensemble model. Okay. Metrics to evaluate categorical data taken. Okay, fine. So thank you so much for joining this session, and thank you so much for being interactive and staying till the end. Okay. So if you have still more questions in your mind, please feel free to add it into D Drive, or you can mail on internship@datamites.com. Okay. Fine, guys. Thank you so much. See you in the next session.